this video, we are going to discuss ICSE 10 Physics MCQs. We are going to discuss MCQs of part 1, that is mechanics. It contains 3 chapters. First chapter is force, second is work, power and energy, and third machines. There are 2 years question papers, specimen question papers and actual board exam papers from 2023 and 2024. So there are no questions on third chapter, that is machines. So we are going to discuss only first 2 chapters, that is force and work, power and energy. I am going to give you answer key. Not only that, but I am going to discuss the solution, its calculations whenever necessary, reasons behind any answer. So let's start specimen paper of 2023. So as we observed, these MCQs are very simple and basic. If you know the concepts, you can easily solve. Each question is for 1 mark. If you are familiar with the pattern of the exam, section A contains 15 MCQs and each question contains 1 mark. As you can see, specimen question paper of 2023. So question is, SI unit of moment is. There are 4 options. 4 options are given in each MCQ. MCQ means multiple choice question. So out of these 4 options, you have to choose the correct answer. So you can see this question, it is very simple and basic. SI unit of moment is, and options are kgf meter, Newton meter, GF meter and Newton centimeter. As we have discussed in our first chapter, what is moment? So what is the answer? Correct answer is option B, that is Newton meter. SI unit of moment is Newton meter. अभी अगर आपको याद नहीं है तो how will you calculate the unit? It is easy. What is moment? Moment is nothing but magnitude of force into perpendicular distance from the axis of rotation, right? So moment is what? Magnitude of force into perpendicular distance. So moment का unit का क्या होगा? ये दोनों का जो unit है magnitude of force का and perpendicular distance का combine, the unit of moment is combined unit of magnitude of force and perpendicular distance. So we know that magnitude of force is Newton and unit of perpendicular distance from the axis of rotation is meter. So what will be the unit of moment? Newton into meter, that is Newton meter. And it is very simple and conceptual question. So answer of this question is answer B, Newton meter. Next question is from actual ICSE board paper from 2023. So next question is, clockwise moment produced by a force about a fulcrum is considered to be option A positive, option B negative, option C 0 and option D none of this. So I will first give you the answer. So answer of this question is option B negative. The correct option is option B negative. We have seen that there are 2 types of moments. One is clockwise moment and other is anti-clockwise moment. Clockwise moment is considered as negative and anti-clockwise moment is considered as positive. So answer to this question is option B, clockwise moment is considered to be negative. Specimen question paper 2024. The question is, a moment of couple has a tendency to rotate the body in an anti-clockwise direction. Then the moment of couple is taken as option A positive, option B negative, option C maximum, and option D 0. As you can see, it is similar to the previous question. So what will be the answer? It is very easy. Here we are taking anti-clockwise direction, right? So no need to discuss again. Moment, when we consider anti-clockwise moment, we take it positive, and when we consider clockwise moment, we take it negative. So answer to this question is positive. Now next, this is actual board exam paper of 2024. The question is a door lock. See, this is a numerical based question, calculation based question. A door lock is opened by turning the lever or handle of length 0.2 meter. If the moment of force produced is 1 Newton meter, then the minimum force required is option A 5 Newton, option B 10 Newton, option C 20 Newton, and option D 0.2 Newton. So this is a numerical and calculation based question, but again this is very simple calculations are there. What is the answer? Answer is option A 5 Newton. Now while solving numericals, we go step by step. First we consider the given data. So what is the given data? What formula we are going to use depends on the question asked. What are we going to find out? So which quantities are given and which quantity you are going to find out. So from the question you can see that what is given, moment of force is given, that is 1 Newton meter. If the moment of force produced is 1 Newton meter. So it is given in SI unit. And what else is given? Length of the lever or handle. So length of the lever is given, it is 0.2 meter. Now you can see that both the units are SI unit. So there is no need of conversion of units. Now moment is given, length is given, and what you have to find out, the minimum force required. So for force we are going to use the formula for moment of force. So what is the formula? Moment of force, moment is equal to force, that is magnitude of force, into perpendicular distance from the line of action of force. So a door lock is opened by turning a lever. Okay, so we will take that perpendicular distance means the length of the handle. Moment is given 1 Newton meter. Force we have to find out, and perpendicular distance is given 0.2 meter. So out of 3 quantities, 2 are given and you have to find out the third quantity. So for force, we take, therefore force is equal to 1 Newton meter upon 0.2 meter. So there is a change of side. So F is at, force is at RHS. So force will be 1 upon 0.2 meter. So 1 upon 0.2 is 5 Newton. What is asked? The minimum force required. We know that to remain the quantity or to remain the magnitude of moment constant, we need to apply the minimum force. So when the force will be minimum, when there is maximum distance, because formula because moment is equal to magnitude of force into perpendicular distance, right? So when the distance is maximum, the force will be minimum. Moment is directly proportional to, yes, you can see moment is directly proportional to the force and directly proportional to the perpendicular distance. So minimum force required is 5 Newton. We are taking maximum distance that is already given, which is 0.2 meter. Okay. Now next question. This is from specimen question paper 2023. We have seen MCQs from first chapter, that is force. Now we are going ahead with the second chapter of first part, that is work, power and energy. So as you can see that only one question of chapter 1 is there in question papers, but there are more than 2 or more numericals or 2 or more MCQ based questions on chapter 2 from last 2 years. So chapter 2 is important while solving MCQs. MCQ based questions are conceptual, so if your concepts are clear, you can score easily. And we will go ahead with chapter 2, that is work, power and energy. You can see question here. Which of the following is the correct expression for gain in kinetic energy if initial velocity is not zero? Option A, k is equal to 1 by 2 mv square. Option B, k is equal to mv square upon 4. Option C, k is equal to mv square upon 2t. And option D, k is equal to 1 by 2 m in bracket v square minus u square bracket complete. So what is the correct answer? Correct answer is option D. K is equal to, K stands for kinetic, gain in kinetic energy. What is asked? Gain in kinetic energy. So K is equal to 1 by 2 m in bracket v square minus u square bracket complete. So first you must know the meanings of this symbol. You must be aware that m, small m stands for mass and v stands for velocity. Now you can see that there are two velocities. One is u and other is v. U is taken as initial velocity and v is taken as final velocity. What is the question? Correct expression for gain in kinetic energy if initial velocity is not zero. Okay, initial velocity is not zero. So initial velocity has some value, that is u. We will see the solution. So there are two kinetic energies, initial kinetic energy and final kinetic energy. So what is general formula for kinetic energy is half m into v square. M stands for mass and v stands for velocity. Now initial kinetic energy, for initial kinetic energy we will take initial velocity. So Ke initial, that is initial kinetic energy, is equal to 1 by 2 mass into initial velocity square, that is mu square. Now what is the final velocity? It is 1 by 2 m into v square. What is asked? Gain in kinetic energy. So what will be the gain? The difference between these two. So kinetic energy, initial kinetic energy and final kinetic energy, the difference between final and initial energies will be equal to the gain in kinetic energy. So increase in energy or gain means there is increase in kinetic energy. So you can simply subtract initial kinetic energy from final kinetic energy. So this is final answer is 1 by 2 mv square minus 1 by 2 mu square. You can take 1 by 2 and m common. So answer is 1 by 2 m to v square minus u square. Okay, it's simple. If you know the formula for kinetic energy, you can easily derive this, and if your concepts are clear, you can easily answer just by looking at the options. It is said that initial velocity is non-zero, so there must be the value of u, and only option D contains u, the term u. So answer is option D. Now we will go ahead. Next question. So next question is again from the same paper. So this is the second question from same specimen question paper 2023. The energy conversion when an oscillating pendulum moves from mean to extreme position is option A, kinetic to potential, option B, potential to kinetic, option C, potential to kinetic to potential, and option D, kinetic to potential and again to kinetic. So we know that there are two types of energies, potential energy and kinetic energy. So there is always conversion going on from potential to kinetic, kinetic to potential. So what is asked, when an oscillating pendulum moves from mean to extreme position, what is the answer? Correct answer is option A, kinetic energy to potential energy. Now we can see that here this oscillating pendulum, here it is tied to a rigid support, and there are three positions. Position B is mean position, position A is one extreme position, and position C is extreme position in another direction. So oscillating pendulum starts, we can imagine that it starts from mean position, it goes to one extreme, and then again to mean position, again to other extreme position. So what is asked, from mean to extreme. So you can take any extreme positions out of two. So mean position is B. So from B to C or B to A. So what is the energy conversion? So it is in motion. So at mean position it will be in motion, and at extreme position it will stop and change its direction, and again it will be motion. So at mean positions there is a kinetic energy and potential energy is zero. So kinetic energy, so from mean position to extreme position, kinetic energy becomes zero and potential energy becomes maximum. So the conversion is, as you can see, from kinetic to potential energy, from mean to extreme position. Now we will go ahead. Next question is from actual board paper of 2023. Question is, when the speed of a moving object is doubled, then its kinetic energy, option A, remains the same, option B, decreases, option C is doubled, and option D becomes 4 times. So this is third consecutive question on kinetic energy. So this topic is important. So what is asked, if speed of a moving object is moving, so it possesses kinetic energy. When the speed is doubled, what will be the effect on kinetic energy? So how will you calculate this? If you know the formula, you can simply put the value and calculate. What is the answer? Answer is option D. It becomes 4 times. How? We know that kinetic energy, if we consider initial kinetic energy as Ke1. So Ke1, we know the general formula for kinetic energy, which is 1 by 2 mv square, where m is mass and v is its speed. So Ke1 is 1 by 2 mv square. Now the speed of the object is doubled. So speed is v. If we double the speed, so what change will happen? Now instead of v to final kinetic energy, instead of v we take 2v. Okay, speed is doubled. Okay, so we have to change the value of v. Here pay attention to the bracket. So we have changed the value of v. So what will be the formula? 1 by 2 m 2v square. Okay. So value of v is doubled. So it will be 2 square, that is 4. 4 into v square. Next question. So next question is from actual board paper of 10th ICSE. It is from question paper of year 2023. So what is asked? When the speed of a moving object is doubled, then its kinetic energy, option A, remains the same, option B, decreases, option C is doubled, and option D becomes 4 times. So what is asked? So there is change in the speed of the moving body, and what will be the effect on its overall kinetic energy. As you know that the body is moving, so it possesses some kinetic energy. So what is the answer? Answer is option D. Correct answer is option D. It becomes 4 times. So how? If you know the basic concept of kinetic energy, what is the formula? So kinetic energy is 1 by 2 mv square. Now what is asked? If the speed is doubled. So if the initial kinetic energy, we take initial kinetic energy as Ke1. What is the formula for kinetic energy? So Ke1 is equal to 1 by 2 mv square, where m is the mass of the object and v is the speed of the object. So Ke1 is 1 by 2 mass into speed square, that is 1 by 2 mv square. Now the speed is doubled, so only the value of v will change. So we take, after changing the speed, Ke2 is equal to 1 by 2 m into 2v whole square. Here pay attention to the bracket. Only the value of velocity is changed, so only the value of speed is doubled. So we take 2v instead of v. So from we substitute the value in second equation, that is instead of v we take 2v, 2 times. Doubled means 2 times. So the formula is 1 by 2 m into 2v whole square. So what is the square of 2v? 2 square 4 and v square as it is. So Ke2, that is final kinetic energy, will be 1 by 2 m into 4 v square. If we take 4 common, if we take 4 outside, so what is observed here? So Ke2 is 4 times 1 by 2 into mv square, and 1 by 2 mv square is the initial kinetic energy. So final kinetic energy is 4 times initial kinetic energy. When the speed of a moving object is doubled, the kinetic energy becomes 4 times. So you have to calculate using the formula, put the values. It's very simple and conceptual question. Now next question. Next question is from the same paper, paper 2023. The energy conversion in a washing machine is from. So it's very simple and theoretical questions. Almost everyone has washing machine at their home. So what we do, so what is the principle or working of washing machine? It's very easy. Now next question. Next question is from same question paper from 2023. The question is the energy conversion in a washing machine is from option A magnetic to electrical, option B electrical to mechanical, option C electrical to magnetic, and option D magnetic to electrical. This question is very simple and theory based question. Almost everyone has washing machines at their home. So what is the principle behind the working of washing machine? There is obviously energy conversion. So what is the working principle? We use electrical energy. We connect the power supply of washing machine at our homes. We connect it to the electrical energy and we use that electrical energy for washing clothes in the form of mechanical energy. So there is conversion of electrical energy to mechanical energy. This is very simple question. So it is observed that there is at least one question from the this chapter based on the energy conversion. So if you use basic logic, you can easily answer these type of questions. So correct answer is answer B, electrical to mechanical. Now next question. This is from specimen question paper 2024. The question is the kinetic energy of a given body depends on the A position, B center of gravity of the body, C momentum, and D displacement. Again there is a question based on kinetic energy. So if you thoroughly study this part, so at least 2 to 3 marks are confirmed. So you can easily solve a question based on kinetic energy. What is asked? Kinetic energy depends on position, center of gravity of the body, momentum, and displacement. The correct answer is option C, that is momentum of the body. Now again we are going to use the formula to find out the answer. So we know that the formula is 1 by 2 mv square, where m is mass and v is speed of the body. Now if we multiply and divide this formula by mass, so we multiply and divide, so both numerator and denominator m, so multiply by m and divide by m. So what will be the formula? M numerator will be mv whole square, mass into mass, and velocity square, and in numerator in denominator it is 2m, 2 times the mass. So as we know that momentum is equal to mass into velocity, so we can replace this term mass into velocity, that is mv, by momentum, that is p. So formula for kinetic energy is p square upon 2m, where p is the momentum of the body. So what is the answer? Kinetic energy depends on the momentum. You can see that kinetic energy is proportional to the momentum square, right? So kinetic energy is equal to p square upon 12. So correct answer is option C, momentum. Next question. It is from the same specimen question paper 2024. Question is, for burning of coal in a thermoelectric station, the energy conversion taking place is option A, chemical to heat to mechanical, option B, chemical to heat to mechanical to electrical, option C, chemical to heat to light, and option D, heat to chemical to mechanical. So this is again from energy conversion. So you can see that from chapter 2 there is at least one question based on kinetic energy and one question based on energy conversions. So what is asked here? Burning of a coal in a thermoelectric station. Thermoelectric. So we are converting energy. The energy conversion, 4 options are given. So what is the correct answer? Answer is option B, that is chemical to heat to mechanical to electrical. So how is this burning of coal? So in thermoelectric power station, what happens? We use coal to ultimately get electrical energy, right? So there is conversion of energy from coal to electrical energy. There is some process, as you can see, when we burn the coal, there is some chemical reaction is happening. So first is chemical energy, and after burning heat is produced. So there is conversion of chemical energy to heat energy. Then we use steam from that heat, that is mechanical energy. That steam is used to rotate the turbines. So it is converted into mechanical energy, and that turbine is again connected to the generator to produce electricity, that is electrical energy. So as you can see that from coal to electricity there is conversion in at least 4 steps, that is chemical to heat to mechanical to electrical. Now next question. So next question is from actual board paper of ICSE 2024. What is the question? Again it is based on the energy conversion. So question is, when a bell fixed on a cycle rings, then the energy conversion that takes place is option A is gravitational potential energy to sound energy, option B kinetic energy to sound energy, option C sound energy to electrical energy, and option D sound energy to mechanical energy. It's very common sense based question. So what is the answer? Answer is option B, kinetic energy to sound energy. It's very easy when while we are on cycle, when the bell rings, what happens? We provide some motion to that ring. So there is kinetic energy, and ultimately we get, when the bell rings, we hear it. So it is conversion of kinetic energy to sound energy. So correct option is option B, kinetic energy to sound energy. Next question. Next question is from the same paper, that is question ICSE board paper 2024. So what is the question? So it is diagram based question. The force F, as you can see in the diagram, there is a triangle. You can see a block near point A. So what is asked? A force F moves a load from A to C as shown in the figure below. For the calculation of the work done, which of these lengths would you use as the displacement? Now, this is based on the work done of the work done by the body. So, this question is based on work done. So, what is asked? As you can see, that load, we are providing some force. Three sides of triangles are given. AC is 5 meter, CB is 3 meter and AB is 4 meter. What is asked? Which length would you use as the displacement? Now, answer of this question is option C, 5 meter. So this is on work done. So we must know the formula for work done. So what is work done? Work done is equal to force into displacement. Now we can see that there is some force acting on this load and there are three displacements. So which length will you use? Obviously, if you observe the figure, the direction of the displacement and the direction of force must be same. So, which direction we will use, which length we will use is 5 meter, because to get the work done, the displacement should be in the direction of force. So, there is no calculation required. You can easily answer this based on the diagram. So, direction of that load and the direction, the length of AC are in the same direction. So, option C, 5 meter is the correct option. If you study properly, conceptually, if your concepts are clear, you can easily solve MCQs based on common sense. We will discuss other chapters in next parts. Thank you.